Okay, 8.4, we are going to solve exponential equations with the variable in the exponent. So I want to give you guys a couple of definitions first. First definition is an exponential equation. An exponential equation is an equation where the variable occurs in the exponent. So it's what we've been graphing so far, like 3 to the power of x, okay? There is a property of equality for exponential functions. So if b is a positive number other than 1, then b to the power of x equals b to the power of y if and only if x equals y. So for example, if 3 to the x equals 3 to the 5th, doesn't that make sense then that x has to equal 5? If 3 to the power of x equals 3 to the power of 5, doesn't it make sense that the x and the 5 have to be equal?
Yes.
Okay, that's what we're going to be doing. Okay, so that's the property of equality for exponents. All right, so the steps to solving exponential equations. The first thing that you are going to want to do is rewrite each side of the equation to have the same base. This is really important, okay? So same base means both of them have a base of 3, both of them have a base of 4, just as long as they're the same base. That's why on Tuesday when we started the unit, I had you guys practice writing numbers as different bases. After you get the same base, so in the example that I gave you above, 3 to the x equals 3 to the 5th, they have the same base. What you can do is you can drop the bases and set the exponents equal to each other, and then you'll be able to solve for x. Okay. Example 1, 3 to the power of x equals 1 over 81.
So that means x would be negative?
Maybe. Okay, so the first step here is we need to rewrite each equation so that they have the same base. This guy has a base of 3. Can we rewrite 81 to have a base of 3?
Yeah.
Yeah, it's 3 to the what? 3 to the 4th. Now, this would give us 3 to the power of x equals 1 over 3 to the 4th. Do you guys agree?
Mm-hmm.
We can't take the 81 out of the denominator yet. This technically is not the same base because 3 to the x does not have a fraction in it, and this 1 over 3 to the 4th is a fraction. So how could I move this up to the numerator?
Negative.
Make it a negative. So this is going to be 3 to the x equals 3 to the negative 4th power. Now that I have the same bases, I can drop them, and I set the exponents equal to each other. So x equals negative 4. There's no solving to do here, so that's your answer. So example 2, guys, 2 to the x equals 1 over 16. How could you write 16 as a base of 2? 2 to the 4th. So this would be 2 to the x equals 1 over 2 to the 4th, and then how do we get that 2 to the 4th up? Make it negative. So this is 2 to the x equals 2 to the negative 4. Drop the bases, so x equals negative 4. That's a coincidence. Okay, so example 3, we have 2 to the negative x plus 3 equals 8. What would our bases be here? What would be our same base? 2. How could we write 8 as a base of 2?
2 to the 3rd.
2 to the 3rd. So this is going to be 2 to the negative x plus 3 equals 2 to the 3rd. Do I have same bases? Yes, so drop the bases, and that gives me negative x plus 3 equals 3. So to solve this, what do I have to do, guys? Distribute the negative. So that gives me negative x minus 3 equals 3. Add 3 to both sides. So I get negative x equals 6. So if negative x equals 6, what does positive x equal?
Negative 6.
Negative 6. 4 to the x plus 2 equals 2.
Can you do that?
Okay, can I even do this? This guy has a base of 4. This guy has a base of 2. What would our common base be?
2.
2. How can I rewrite 4 as a base of 2?
2 squared.
2 squared. So this is the same as 2 to the 2nd power times x plus 2. So you just bring the square up, equals, now 2 by itself is the same as 2 to the power of what? 1. Okay, so I started it for you. I want you guys to finish it. So the next step would be to drop the bases, and you get 2 times x plus 2 equals 1. Now finish the rest of it. Okay, guys, what would be your next step to solving for x? Distribute the 2. So 2x plus 4 equals 1. Then what? Subtract 4. So 2x equals negative 3, and then divide by 2. So x equals negative 3 over 2. It's okay to get a fraction. That would be your answer. Example 5. 7 to the 2x equals 49 to the 3x minus 2. Guys, what would my common base be?
7.
7. So this one doesn't change. 49 is the same as 7 to the
7.
second. So that's going to be 2 times 3x minus 2, right? Finish it. Okay, guys, what did you do next? Drop the bases. So this is 2x equals 2 times 3x minus 2, and then what? So 2x equals 6x minus 4, and then what did you do? Okay, so subtract 6x. So that's negative 4x equals negative 4, and then divide by negative 4. So x equals positive 1. How many of you got x equals 1? Fabulous. Okay. All right, number 6. 9 to the 2x equals 27 to the x minus 1. Okay, I have a base of 9 and a base of 27. Can I rewrite 27 as a base of 9? No, but I could rewrite both of them as a base of what? 3. So this is going to be 3 to the second times 2x equals 3 to the what? Third times x minus 1. Good. So now we can drop the bases, and we get 2 times 2x equals 3 times x minus 1. 2 times 2x gives me 4x, and then distribute here. So equals 3x minus 3. When I subtract 3x from both sides, I get x equals negative 3. Example 7, 81 to the x minus 3 equals 1/3 to the 5x minus 6. Okay, guys, what would my bases be? This is a 3, or this one we can get it as a base of 3, and this one's an 81. What could they be?
3.
A 3. 81 is the same as 3 to the what? To the 4. So that's going to be 3 to the 4 times x minus 3. Now this one is a little tricky because it's a 1/3 to the power of 5x minus 6. This thing is not a base of 3 yet. It's a 1/3. So how could I move that 3 up? Make it a negative. So this is going to be 3 to the negative times 5x minus 6. So whenever we want to move our base up, you just make it negative. In this case, there isn't another exponent attached to this 3, so we just put a negative 1 there. So now I can drop my bases. Are you guys okay if I distribute in the same step? Okay, so that's going to be 4x minus 12 equals negative 5x plus 6. Add 5x to both sides.
Is this getting harder than this?
So that's going to give me 9x minus 12 equals 6. Add 12. So we get 9x equals 18. So x equals 2. Okay, so Stephen wanted to make it harder. So, number 8. 3 to the x equals the square root of 27. Right. First of all, what would my base end up being?
3.
3. So let's rewrite that first. So this is 3 to the x equals the square root of 3 to the what?
3rd.
3 to the 3rd. Okay. I need to get that 3 to the 3rd out of the square root. How can I rewrite this
Square.
so that it doesn't have a square root in it?
Square then.
Well, a square is not, you could square both sides, but there's actually a better way. What kind of exponent is a square root? Do you guys remember?
2. What?
1/2. Okay. So we rewrite it as a fraction. Remember when we were going back and forth between roots and fraction exponents? So if you have a square, whatever your root is, that's your denominator. This one is still your exponent. Now I have the same base, right? So drop the bases, and x equals 3 over 2. Okay. Most challenging one is number 9. 5 to the x equals 5 times the square root of 25. Okay. Can we take the square root of 25, guys? What does it come out to? 5. So let's rewrite this as 5 to the x equals 5 times 5. So that gives me 5 to the x equals 5 to the what? 2nd. I have a lot of students that always forget this and they leave it as just 5 to the 1st. Remember that 5 is still there. So 5 times 5 gives me 5 to the 2nd power. Drop the bases and x equals 2. Okay. I know it wasn't as complicated as I knew. Last one. 1 over 8x equals 1 over 4x to x plus 1, to the x plus 1. Guys, question. Is 4 to the 2nd power 8?
No.
No. So please, I guarantee one person will forget and put that 4 to the 2nd power is 8. If I have an 8 and a 4, what actually should my base be?
2.
2. So let's rewrite it first. This is going to be 1 over 2 to the 3rd to the x equals 1 over 2 squared to the x plus 1. Okay, I want my bases to be in the numerator, so that means I'm going to make both of them negative. So this is 2 to the negative 3x equals 2 to the negative 2 times x plus 1. Drop your bases. So negative 3x equals negative 2x minus 2. Add 2x. So we get negative x equals negative 2. So that means positive x equals
2.
positive 2. That's solving with exponents in the variables in the exponent.